Hello friends, welcome to this course on LS DYNA. In this lecture, we are going to start with our first analysis in LS DYNA, and we are going to start with very simplest type of analysis that is called ball hitting a plate. Now in this problem, a ball is hitting a plate and our objective is to simulate this problem. Now let's understand the problem first and then we will go to LS DYNA to solve this problem. Here we can see in this picture we have a plate and we have a ball, and this ball is going downward and then this ball is hitting the plate. So here we can see the dimensions of this plate. This plate is of 10 by 10 meter. Thickness of this plate is 5 mm and the ball is of diameter 4 meter. So here we are going to create the ball as a solid part, and for the plate we are going to use the shell element. It means we are going to use the mid surface and then we will apply the thickness to that mid surface. So in LS DYNA, when we solve any problem, we need to follow these steps. Now the first step of course will be to create or import the geometry. So in this step, if we have any existing geometry, we need to import that, or if we want to create the geometry in LS DYNA, we need to do that. After creating the geometry, our second objective is to create the mesh. So we have different types of mesh available in LS DYNA. So according to that part, we need to create the mesh. After that, we need to properly select and create the material property, and then we need to apply that property to each component. Material properties are one of the most important part of LS DYNA simulation. So it is very important for you to have a good understanding of material in LS DYNA. After creating the material properties, we need to apply the loads and boundary condition to the problem. So in this step, we are going to apply the load just like pressure, force, etc. And then we are going to fix the object according to the situation. In the next step, we need to apply the contact between the bodies. So in LS DYNA, we have a huge library of contacts, so we can apply the contact according to the situations. After that, we need to create the section property and then part. So we are going to learn about each step one by one when we perform the analysis. After that, we need to do the analysis step. In this, we are going to insert all the properties and values for the output. So we are going to cover this later in this lecture series. So first, let's go to LS DYNA and we need to create the geometry. So before that, let's understand different dimensions of this object. So for this plate, we are going to create this plate using the 4 coordinates. Here we have all the coordinates. We are going to create this object just like it is showing into this XYZ system. So Z direction is in perpendicular. So we are going to take Z0 in all the coordinates. Similarly, for the ball, we are going to take the spherical ball of radius 4 and this value of center. Unit system in this problem, we are going to follow in the Newton, meter, second and kg. So in LS DYNA, we have to be very careful about the units. So we have to be consistent in the units. So now let's go to LS DYNA and create this problem. So right now I am in LS DYNA program launcher. First of all, I will go to this option of LS prepost. Click on this and click on start LS prepost. I will click OK and then click close from here. Now here, first of all, I am going to create the plate and the ball. Now for this, I will go to this option of FEM. Click on this FEM and then I will go to element and mesh, and here we can see shape measure. Click on this. Now here we can see we have multiple options. Click on this entity and here we can see 4n shell. It means 4 noded shell element. I click on this. Now here we need to specify the coordinate values P1, P2, P3 and P4. After that we need to select the mesh size. It means how many number of elements we are going to create along both the axes. So first of all, let's start with this coordinate values. So here we can see we need to insert all these value of coordinates. So first is -10, -10, 0, then 10, -10, 0, then 10, 10, 0, then -10, 10, 0. After that we need to select number of element in x direction and number of element in y direction. So let's say number of element I want to select 20. So it is basically the size of element. So I select 20 on both directions and the spacing between each step is 1. So later on if we want to change these values, we can change according to the requirement of mesh. I am taking some initial values. After that we need to select the name of this body. So this is plate, and then we need to create some part ID. So let's say part ID is 1, and then we need to select the element ID. So when we create the plate, elements and nodes will be created. So here we can specify the ID of each element. It means at what value the element ID is going to start. So here we can insert any value. So let's say I want to start with 401. So all the element ID will be started with this 401. Similarly, let's say for node, I will select some different value. So let's say this is 501. Click on create. Click on accept and click done. Now let's rotate this. So when I rotate this, we can see a plate has been created. So we selected the number of element 20 in each direction. So if we count the number of element, you can see from this left to right side it will be 20. After that we need to create the spherical ball. To do this, first let's find out the dimensions of this. So the dimension of this ball is radius 4 meter and the center is 005. So I will go to FEM, element and mesh, shape measure. Here I will go to sphere solid. So basically we have two options, spherical shell ball or solid ball. So shell ball will only create the hollow type of ball, but we want a solid ball. So click on this sphere solid. Now here we need to specify the radius. So radius is 4. Now here we need to specify the density. So density means density of the meshing. So let's say I want to create a element of size 5. So initially we are going to start with the element size 5, and if there is any requirement of changing, we can change it later on. So let's say this is 5, and then we need to specify the center. So center is 005, so pick this value. So put up value of z is 5, and then we need to specify direction 1 and direction 2. So direction 1, direction 2 basically specify the direction perpendicular to the radial direction. So it means the radial direction will be along z. So perpendicular direction will be along x and y. So insert the value 1 1 in the perpendicular direction to this z. So dx is 1 and dy is 1. After that we need to specify a target name to this body. So this is ball. Part ID, we need to insert some different value of part ID. So part ID should not conflict with each other. So it means no two parts should have common part ID. So initially it was taken 1. Now for this part it is 2. Now start element ID. So we can take some different element ID. Initially we specified 401 for plate. So take some different value. Let's say this is 801. And node ID is, we can take any different values. Click on create and then click on accept. Click done. Now we can see the plate and the ball has been created. So after that, if we go to the steps of analysis, so we have created this geometry and the mesh, we need to create the material. So we are going to follow up this step in the next lecture. So I will go to LS DYNA. I am going to save this. So you can go to file, save as, go to save keyword as. In this save format, we need to browse the location. So go to C folder, go to LS DYNA where the software is installed. So here I will create a folder that is project file LS DYNA. Inside this I will create another folder. So plate and ball impact. Inside this folder I will insert the name ball plate impact. So we have to make sure there should be no space or point in the name. So in LS DYNA, whenever we specify any name, there should be no space and point. Otherwise it will show any error when we solve this problem. So _1 and save as. And here we need to select the output version. So right now the latest version I have is R10. So if you have any older version, you can select this version. So let's say if you have any older version, I am saving this file in R8 version. Click save. So you can use this file if you want to continue with me. So we are going to follow this in the next lecture. In this lecture, we will continue with ball impact problem. So in the previous lecture, we had created the geometry and we have created the mesh in the ball plate impact problem. So let's go to LS DYNA. So if you want to work along with me, you can go to this file, click on open, click on LS DYNA keyword file, and we will open up the file that we had saved earlier, that is ball impact _1. So select this file and open. In this file we can see we have created the mesh. After that, if we go to this steps, we have created geometry and then mesh. After that we need to define the material properties. So if we go to the material properties, here we have defined the material like this: the plate and the ball. For the plate, we are going to use this material card, that is MAT 024, MAT piecewise linear plasticity. So to define the properties of plate, we are considering up to the plastic limit. In case of ball, we only taking the elastic ball. Now to define the plasticity, we need density, Young modulus, Poisson's ratio, yield stress, and then tangent modulus. And after that, for the ball, we are going to take MAT 001, MAT elastic, density, Young modulus, and Poisson's ratio are given. So in this problem, as we already know, we are working in the units of meters, and all these given values are in millimeters. So 1 megapascal equal to 1 Newton mm square. So when we convert this in meters, we need to input the value 10 to the power 6, or in the FPA software we put e to the power 6. Similarly, when we have gigapascal, then we need to use e to the power 9. So if we go to the material properties, we can see we have general stress strain curve. When we consider only the plastic properties of the material, we are going to define all the properties up to this plastic limit. So here we can see up to this curve, this is the elastic zone. And when we want to input the plastic zone, we need to go further into this curve and we will consider this plastic curve. This is plastic zone. Similarly, there is one more term that is called yield stress and tangent modulus. So yield stress is basically the maximum stress after which the plastic zone starts. So this is the point of yield stress. Similarly, when we want to define the plasticity, we have multiple options. Like we can define different point for this curve, or we can define that is called tangent modulus. Tangent modulus is basically the slope or the area under this curve at this point of yielding, at the point from which the plasticity starts. So you can find all the details about this in any book of material science. I'm just going to give you a basic overview. Now let's go to LS DYNA and define the material properties. Now to define the material in LS DYNA, we need to open the keyword manager. For this, I will go to this option of FEM, go to model and part, and here we can see keyword manager. Open this. Now inside this keyword manager, it is going to show all the properties that we have already created for this model. Like we have created element, keyword, node, part and title. I will go to this all, and then we need to go to M part. So go to M and here you will see mat. Now click on this plus symbol along with this mat, and here you can see all the material library in LS DYNA. So in LS DYNA we have more than 100 types of different materials. Now we need to go to our specific material. So I will go to this number 24. In the number 24, this is the most general material that is defined in LS DYNA, piecewise linear plasticity. I will make a double click on this. Click on add. Insert the name, that is plate material. So let's say that is plate plastic material. After that we need to input the values. So density is 7850, and then here we have to define Young modulus. So Young modulus is 209 e to the power 9. Poisson's ratio is 0.29. So whenever I click on any of the box, it will highlight the corresponding value. So when I click on this PR, here it is going to show Poisson's ratio. So after that we need to define the yield stress. So we know yield stress is 500 megapascal. So 500 e to the power 6. And then we need to define the tangent modulus. So tangent modulus is 10 gigapascal. So 10 e to the power 9. Okay, rest of the properties, if we want to define the points, we need to define this EPS1, EPS2, ES1, etc. So we will cover this later in the course. Now I will click on this accept, click on done. So when I click on the accept, you will see the material here. It means we have properly defined the material I will click on done. Now for the ball, I will go to this mat 001. You can see 01 elastic. Double click on this. Click on add. Now give it some name like this is ball elastic. So density is 2850. Young modulus is 72 gigapascal. So e to the power 9. And Poisson's ratio is 0.3. Here we don't need to define any more values. So just click on accept and click done. So when any of the property is defined here, it is going to highlight into this blue color. You can see also here in the 24 number, it is going to show the blue color. Now click on done. If you want to find out more about all these material properties, what you can do is go to your C drive, and here the LS DYNA is installed, LS DYNA, and go to manuals. Inside this manuals, open this. We have 3 manuals, 1, 2 and 3. Open up this model. Open up this manual number 1. Inside this manual number 1, you will see all the manuals and all the keyword in detail. For the material, we need to open that is volume 2. Inside this volume 2, we have mat. Click on this plus symbol, and let's say I want to find out all the properties of mat 24. So click on mat 24 here, and now you can read everything about this. So this is mat 24, mat piecewise linear elasticity. So here everything is defined in details. So you can read about this by yourself. So after that we had defined the material, we need to define the boundary conditions. Boundary condition means in this problem we have to specify 2 boundary conditions. One is we need to fix this plate, and then we need to apply the velocity to this ball. So the ball is moving with a velocity of 10 meter per second in the perpendicular direction to this plate, and this plate is fixed in all the 4 sides. Now let's go to LS DYNA. Now to apply the boundary conditions, I will go to this FEM model and part, and then go to create entity. So we will continue this in the next lecture. Hello friends, in this lecture we are going to apply the boundary condition to this plate and ball. Now to apply boundary condition in LS DYNA, we need to go to this FEM, go to model and part, and you can see create entity. Click on this. Here first of all I am going to fix the plate. Now to fix the plate, we need to go to this boundary option, and here you can see SPC. SPC means single point constraint. Now inside this single point constraint, I will click on create, and then I will go to this view browser, click on this arrow, I will click on top. So in this way I have rotated this to the top view. After that I'm going to make a check on this XYZ, RX, RY and RZ. So it means I'm going to fix the motion in all directions, XYZ and rotation about XYZ. Now we can select nodes one by one. So here I will click on this pick, and here in the filter I will click by node. So we can select node one by one like this, and there is one more option to select the nodes quickly. I will click on this area, and then take the mouse somewhere outside this plate, and then hold down the left click, and you can see a window. This is basically a selection window. Just insert the nodes inside the selection window like here, and you can see all the nodes are selected. Similarly here, hold down the left click and drag the mouse, and then similarly here. So in this way we can select all the nodes. So you can see all the nodes are properly selected. I will click on apply. Click on done. So when I rotate this, we can see it is going to show boundary condition onto all these nodes. Similarly, you can also see the boundary condition inside this model tree. Click on this plus symbol and you can see SPC. After that, we need to give a velocity to the ball. Now to give the velocity to the ball, I will go to FEM, model and part, and go to create entity. See, the ball is moving with a velocity of 10 meter per second. First of all, let's select the direction. We know the ball is moving in the Z direction. So the positive Z is going upward. We need to go in the downward direction. So here I will go to initial and go to velocity. Here we need to specify velocity like XYZ or rotational velocity like rotation about XYZ. So about X, this is 0, Y is 0. In the Z it is going negative direction, so it is going to be negative 10. Now we need to select this ball. So here what I do, in the type of filter, I will have to select the complete ball. So I will select by part and select this ball. Click on apply. So when I zoom in onto this ball, you can see these arrows are going downward. It means the ball is properly selected. I will click on done. So in this way we have defined the boundary conditions for this problem. After that we need to create contact between the bodies. Now to create the contact, I will have to go to FEM, go to keyword manager. Inside this keyword manager, I will click on collapse all. After that I will go to contacts. So here search for the contact, expand this. Now in LS DYNA there are a number of contacts for different type of situation. For this problem we are going to take the simplest type of contact, that is called automatic contact. Now inside this automatic contact I will select automatic contact surface to surface, because two surfaces are in contact, and this is one of the most common type of contact in LS DYNA. Make a double click on this. I will click on add, and here in the title give it name like this is plate ball contact. So give it some relevant name. This is contact. Now inside the contact we have two options. We need to define slave segment and we need to define the master segment. So basically we need to define two surfaces that are in contact. Since the ball is hitting the plate, the ball is going to be the master body. Okay, and the plate is fixed, so it is going to be the slave body. This is a general consideration when we select master and slave body. Now if I directly click on this SSID, click on this point highlighting, you will see it is asking for a new set segment. I will click on cancel. First of all we need to select correct filter for this. If I click on this SS type, whenever we have segment ID we are going to select the value 0. When we have shell element we need to select the 1. When we have part ID we need to select the 3. So right now we have part ID. So in the type I am going to select 3. Similarly here 3. Now in the slave click on this point highlighting. So slave is plate. Click on this. Click on done. We can see part number 1 is selected here. Similarly in MSID select this ball 2. Click done. Now you can see the ball 2 is selected here. Click on accept, click on done. So if you make a double click on this, you can see the ball plate contact here. And if you want to make any change here, you can change this and once again accept the values. Click on done. After that we need to create section property and part. So basically in this section property and part, we are going to apply all the properties like shell property, solid property, material to individual part. So I will go to LS DYNA once again. First we need to create the section. So I will go to FEM. So you can also find the keyword manager here. You can see keyword manager. Click on this, collapse all. So I will go to section. So you can see the section here. So the plate is made of shell element. For the plate I am going to select shell. Double click on this. Click on add. Give it the title name like this is plate shell. Now the thickness of this plate is 5 mm. So in meter unit it is going to be 0.005. Press enter. Now here we need to select element type. Now in LS DYNA we have a large number of elements. So we have element from EQ1, EQ2, EQ3, etc. Correspond to each type of element we have number of integration point that are called NIP. Now if I click on this element form here, by default it is going to take this type of element. So if we go to the manuals, open the manual number 1. Inside this you go to the sections. Now inside this section go to shell. So inside this shell, if we go to the element type, you can see in LS DYNA we have different type of element form, EQ1, EQ2, etc. So by default the software is going to take EQ2, that is this type of element. Similarly, corresponding to each element here, correspond to each element we need to select the number of integration point. So when I take the EQ0, we need to set this to 2. When EQ is 1, we need to put this value 1. And when EQ is 2, we need to put this value 2. So here in this problem we are going to take the default element, that is EQ2. Okay. So later on in the course we will understand in more depth what are these different types of element, what is this NIP, etc. So right now just insert the value and click on accept. Done. Now for the ball, since the ball is a solid ball, I will double click on this solid. Click on add. This is ball and this is solid. Now for a solid ball we need to properly select the element form, like so here you can see 1, -1, -2, 0, 2, etc. When I go to this element EQ2, it is going to show fully integrated SR. It means reduced solid. So these are solid element. So we are going to take EQ2. So in LS DYNA we have to be very careful about selecting the elements. Click on accept, click on done. After that we need to assign all these different types of property to each part. So I will go to keyword manager once again, collapse all, and then go to part. So here go to P, part, double click on this. So since we have already created the part, we can see the parts are created. One number is plate, second is ball. So we need to apply the section and material to all these parts. Select this plate, click on this section ID. Select plate shell. Done. Define the material for this. Click on this. This is plastic plate and done. Click on accept. Go to ball. Go to section ball solid. And for the material ID, select ball elastic. Click done. Click on accept and done. So now we had defined the part. After that we need to define the analysis setup, means the output settings. So we are going to cover this in the next lecture. So far in this problem of ball plate impact, we had defined all the boundary condition, contact and section IDs. Now we are going to define the analysis setup settings. So basically in the analysis setup settings, we need to define end time. End time means the time interval for which the analysis is going to take place. Then binary D3 plot, ASCII plot, and in the end we are going to model check. So I go to LS DYNA, I will go to FEM, model and part, go to keyword manager. Here click on collapse. Now I will go to the control card. Inside this control I will go to termination. So here you can see termination. Double click on this. In this termination we need to define the time interval for which the analysis is going to take place. And by default we are going to take the second units. So it means 1 second. Click on accept and click done. After that we need to define D3 plot. So with D3 plot we see all the stresses, displacement, etc. So that is why it is very important to define the D3 plot card. So I will go to this database and here go to binary D3 plot. Make a double click on this. Here we need to define the time interval between outputs, or we can define number of points. Now let's understand the meaning of this. See, for the time interval we are going to solve this problem for 1 second. Now I am going to tell the software to calculate the specific value at a certain interval of time. So let's say from 0 to 1 second, I want the software to calculate the different values at 10 steps. It means it is going to divide the time into 10 steps and it is going to calculate all the values. Second is we can define a time interval. It means we can define, let's say time interval is 0.1 second. At each 0.1 second it is going to calculate the values. So that is a difference of selecting these values. So here either we can specify the time interval or we can specify the number of steps. So let's say number of steps I want to define 10. Now it is going to show the values between 0 to 1 second at 10 intervals. We will understand this in more depth when we will see the results. Click on accept, click on done. Now if we want to find out the energies of the system, we can also define the ASCII card. It is an optional, so make a double click on this ASCII. Here once again we need to define default DT. Again this is the time interval, means the smallest time interval for which it is going to calculate the values. So let's say I want to calculate value at each 0.1 second. Now here we need to define two cards in this problem. Since we want to find out the energies of the system, one card is GL state, that is global state. Click on this. Also we need to define the energies of material level. So we need to define MATSUM. So make a check on this MATSUM, that is material energies. We need to only insert these two cards in this problem. So if you want to learn more about these cards, what are these? First I will click on accept and done. So once again you can go to the manual. Inside this manual you can go to database, and here you can go to S key, or you can directly search for GL state. So let's say I select GL stat, enter. So it means it is going to show the global data, and if you will continue selecting, so here it is showing. So with this GL stat file, it is going to calculate kinetic energy and internal energy. Okay, so again you can read about this in the manuals, and after that we need to check the model. So once everything is done, click on collapse all, click on model check, and after that I will go to keyword check. In this keyword check, make sure there should be no error highlighting. Right now it is showing any warning for the section, so we can check for the warning if there is any problem. So right now all the inputs are correct. I will click on done. Click on done once again. So now everything is selected properly. I can go to this file. Now we need to save this file. So go to save as, save keyword as, browse the location and go to the folder where the LS DYNA is installed. So I will go to this ball plate impact. So I have selected this _1 _2 correspond to each lecture. Now this is my final file. So this is ball plate impact final file. I'm going to save this in some older version. So if you have any older version, you can open up this file, click on save. Now we need to run this. I will go to file, go to run LS DYNA. First of all, if any older analysis is showing, click on this remove. First of all, we need to select the input. Click on this browse, go to the folder of ball plate impact, select this file, ball plate impact final, and open. After that we need to select the solver. Click on this, and LS DYNA has two solver, D solver and S solver. So I am selecting S solver, and then in the expression we need to select this expression. Here we can define number of CPUs according to our configuration of the computer. So my computer has 4 CPUs. We can specify any memory to this. Okay, right now I'm selecting auto memory here, and then click on the symbol of play and start the analysis. Now we can see analysis has been started. So it is not showing any error. It means our inputs are correct. Here it is going to show the estimated time. Once the analysis is completed, it is going to show like normal termination. Press any key, press enter, and here you can see analysis is finished. So in the next lecture we are going to view the result. In the previous lecture we had solved this problem of ball plate impact, and we can see the solution has been completed successfully. Now we are going to view the results. Now to view the results, first of all I will cancel this window. I will go to file and I will go to open. Here we need to open up this file LS DYNA binary plot. Click on this, go to the folder where the file has been saved, and we see one option that is called D3 plot. Click on this D3 plot. We don't need to open this file 01 and 02. We need to open the original file D3 plot. Click on open. So in the D3 plot file all the results are stored. So now let's rotate this file and then click on this forward option. Click on forward, and you can see how the ball is going to impact on the plate. So here we can see state, and inside the states we can see the maximum number of states are 11. Since we had defined the 10 number of interval between 0 to 1, and it is going to take extra 1 for the 0 time, so that is why it has 11 states, and that is the advantage of selecting the time interval or dt value. Now let's say I want to view the results. To view the result, we need to go to this option of post. Click on this post. Click on this first option, fringe component. Now inside this fringe component, first I want to calculate the stresses. And in case of impact problem, we need to find out the stress that is called von Mises stress. Click on this and click on done. Now we can see how the von Mises stress is changing, and we want to find out von Mises stress for the last stage. See, click on this stop. Now let's go to each state one by one. First go to state number 1. Here it is showing state number 1. Then click on this next state. Now this ball is coming near to this plate. Then state number 3, the ball is impacting. State number 4, 5, 6, 7. Now at the 7th state we can see the ball is reversing back. At the 8th we can see it is bouncing back once again, like this. So for each state we need to find out the maximum stress, and we can see maximum stress will be like this. So this is the value of maximum stress, 3.62 e to the power 8, and this is in the units of, so we can change this to mm and you can find out the exact stress here. Now let's say I want to find out the displacement. So I will once again go to fringe component, click on NDV, nodal displacement velocity. Here we can specify velocity in any direction here. I will select result displacement, click on done, and then we can forward this. You can see how the displacement is changing here. So the maximum displacement will be in 11th state. So at the state number 7 it is 3.4. After that step the ball is going to bounce back. We can also pick this handle to increase or decrease the speed of animation. So when I increase this, the animation is going to speed up, and when I make a check on this, it is going to continue show the animation. After that, since we had defined the SKI parameter in the database, we can also find out the energies. To find out the energies of the system, go to this history card. Here we had defined the GL state, so that is global state. So click on global, hold down the control key and select kinetic energy and internal energy, and then click on plot. Now inside this plot we can see this red color is showing the kinetic energy of the system. So initially the kinetic energy is maximum, and after that when it is going to impact like this, the kinetic energy is going to decrease. But after this time the ball is going to bounce back. It means once again the kinetic energy will increase slightly and then it will decrease. And here this is the internal energy. So initially the internal energy will decrease, and due to this collision the internal energy is going to increase, and when the ball will bounce back it is going to decrease, and then it is constant. You can go to this attributes and you can check. See, when I click on this internal energy, it is going to show in this green color. It means this green is internal energy. Similarly, when I click on this kinetic energy, it is showing red color. So here you can change all the properties like thickness of this line, etc., line style. I click on quit, click on done. Another way of viewing the result is we can go to this velocity option. Go to velocity vector. Here we need to select velocity, click on dynamic and click on apply. Okay, now let's view the animation. So decrease the speed, start the animation. See, initially we can see these arrows are highlighting. This is the step number 1. So now we can see the arrows are going downward. After that, step number 2, 3. Now when the ball is going near to the plate and it is impacting, again step number 4, 5, 6. So in this way we can view the result like this. I click on done. So in this way we can view the result in LS DYNA.